I am doing number 23 here about car booster seats. The National Highway Traffic Safety Administration collected crash tests of child booster seats for cars. Listed below are the results from those tests, with the measurement giving in HIC, which is Standard Head Injury Condition Units. The safety requirement is that the HIC measurement should be less than 1,000. Use a 0.01 significance level to test the claim that the sample is from a population with a mean less than 1,000. Okay, so first, we're always going to start by making our null. So our null here is that it's 1,000, okay? And then our null, what we're trying to prove, is that it is less than 1,000, okay? So does this suggest that all child booster seats meet the specified requirement? Okay, and we're given data here. So to do this in Excel, not in Excel, on the TI, we are going to have to start by inputting the data. So I'm going to do that before I do anything else, even before I draw the picture, because I know this is going to be a pain in the butt to deal with. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to put it into one of my lists. So I think I got a bunch of lists here. I'm going to put it into list 5, because that's empty right now. 774, 649, 1210, 546, 431, and 612. Okay, so I put in my 6 values. Now, first of all, we've only got 6 values, and they're kind of all over the place. This probably is not normal, and it's not over 30. This is not a great sample, and you wouldn't want to put a ton of faith into these results. Just a heads up, you know, looking at this, you're like, that's a really small sample, and that's kind of crazy data. So you can see we've got a huge variety. So, you know, it's a good example for this. Is it great data? No, not really. So anyways, I put it in. That's my first step. Then quit out of here, okay? So now, what do I want to prove? Well, I want to do a one-tailed test, okay? And I want to prove less than. So I'm over here. I want to be in this tail, okay? And I want 0.01 out here. So I need to look up this value. So you can do this on the table. You can use this. So I'm going to do second vars to get my distribution. I'm going to go to inverse t, my area. Now I've only got one, so I get to put the whole area there. My df, okay, I have how many values? 2, 4, 6, so my df is 5. And so my value here is negative, and I'm on the negative side, so I am going to keep the negative 3.365. Okay, so I would need a value that is smaller than that, okay? But I need to find my t-test statistic to compare with. So I'm going to come here, and I'm going to come to my stat menu. I'm going to go over to tests, and I'm going to go to t-test, okay? Nice and easy first. I'm going to go to data, okay? And then what I'm going to do is here, what am I'm testing? I'm testing 1,000, okay? Because that was what, that's right here. This is where I'm getting it. Okay, I'm going to go pull my list. So I'm going to do second stat. I'm going to find which list I want. In this case, list 5. Okay, frequencies 1. I am testing less than, let's see here. Yes, less than this one right here. Okay, and then I hit calculate. So you can see my test statistic is negative 2.66. My p-value is 0.04. Okay, but so I was testing at 0.01. So mine is negative 2.66. This is not smaller than this. It would not be in the yellow area. This p-value is not less than 0.01. So I would have to fail to reject. I am going to be unable to prove that the mean is less than 1,000. I don't have enough data. The reality is I would need more data to prove anything. You know, as we said from the beginning, being that small, you would have had to have really consistent data. We didn't. So we weren't able to prove anything exciting here. That's okay. And you can see here that, oh, actually, did I screw this up? I see the not up there. I was wondering if I said, or did I actually get it? Come here. Oh, for Pete's sake. Oh, it must have not moved over. Okay. I know I put my thing on there, but it must not calculate. It's this t value isn't going to change. You'll notice this got cut in half. We're still not under it, but and we already knew that because of that. But this is where it changes. The p-value changes because it's less than. But you can see here, this should be your. And this is how I knew something wasn't quite right here. This should be your alternative hypothesis, and mine wasn't because obviously, well, I put my cursor on it. I must have not hit enter. So that, anyways, this is how you can get your TI to do it. The only thing it won't give you is that critical value. This, you'll have to look it up separately, but the TI does that as well.